Every century has an innovation that not only changes the path of humanity, but that of the entire world. In the 11th century, we got windmills, the 15th gunpowder, steam engines in the 18th, and the internet in the 20th. But what about in the 21st? Some may argue AI, while others may say it's too early to tell. But I believe the true fate-changing innovation is one we're all too familiar with. Every day we use energy to power our cars, lights, machines, and to watch this very YouTube video. But this energy, this absolute necessity, is running out. At our current rate, we only have 38 years left to oil, 153 years left to natural gas, and 403 years left to coal. Meaning in our lifetimes, non-renewables will begin to run dry. But renewables are about far more than fixing a problem and replacing a pre-existing resource. Now, renewables are an unlimited power source only bound by your imagination. 430 quintillion joules of solar energy hits Earth every hour. That's more energy in an hour than the amount every human uses in a year. And that's just the energy a single star produces directed at our planet, not the other septillion stars creating an unfathomable amount of energy every second. So in this video, we're not going to look at the same solar panels and wind turbines you have seen so many times before, but instead we're going to look at the true future of energy production at a much, much deeper level. With that being said, I'm going to start us off with nuclear fusion, one of the renewables that are often forgot about yet hold the most potential. Best put by PBS Spacetime, why build a cage around the sun when you can build a sun in a cage? And that's exactly what nuclear fusion seeks to achieve. In a nutshell, it's the same process the sun uses to produce virtually unlimited energy by combining two light atomic nuclei to form a heavier nucleus, which produces a monumental amount of energy. It's predicted the energy output from 1 kilogram of deuterium and tritium would produce 26 million kilowatt hours of energy. That's enough from one cycle of fusion to power 2,600 homes for an entire year. But fusion would power a lot more than that. It would power data centers used to run AI, factories to produce products, farms to produce food, and be used as deep space propulsion to explore far-off planets. The best part is this reality is not far off. We already have seen a huge impact from nuclear fission reactors, with 440 operational worldwide and 64 in the process of being built. Even if the name fission doesn't immediately ring a bell, I'm sure you've heard of events like Chernobyl or Fukushima, where nuclear reactors malfunction, leading to the evacuation of entire cities. I highlight this because this is where the advancements of nuclear fusion become so important. Since fission is just the opposite of fusion, needing to separate atoms instead of combining them, it requires heavy earth elements like uranium or plutonium. These elements are radioactive and produce harmful byproducts, unlike fusion, which uses some of the most abundant resources, such as deuterium or tritium, which can be produced from mere water and generates mainly helium as a byproduct. And since we're on the topic of the sun, I just want to look at putting a cage around the sun because it's arguably the coolest mega project ever proposed. The concept of a Dyson Sphere isn't new. In fact, it was first proposed by Friedman Dyson in 1960. The idea has since become so influential that the Kardashian scale was invented just 4 years later. This scale measures civilization's technological advancements based on the amount of energy it can harness and use. A civilization with the Dyson Sphere would be classified as a Type 2 civilization since it can harness the energy of its entire star. Currently, humans are still far off, only being a Type 0.73 civilization, but that could soon change if humans are able to harness the energy of our entire planet through renewables. In concept, it would be made through largely disassembling Mercury for the materials needed to make mirrors, and launching them into space to orbit the sun in a swarm of roughly 30 quadrillion. These mirrors would direct solar power to energy collecting stations, which then can be sent out to other planets. So in a way, it's like combining Starlink with a large-scale solar farm. Now, of course, this idea is far off and won't be happening for the next few hundred, if not thousands of years, but the only way we can get on track to building a Dyson Sphere is if we break away from the confinements of non-renewable energy. Besides, we really don't need a Dyson Sphere for renewable energy to be the innovation of the century. Currently, over 1 billion people still live without reliable access to energy, mostly because of the infrastructure requirements needed to refine and produce energy from natural gas or coal. The ability to make microgrids through solar panels or wind turbines is playing a massive role in expanding energy reliability to those in the sub-Saharan Africa or South Asia. In other cases like Arctic research bases or the International Space Station, renewables may just be the only way to get power. As long as you have wind, solar, or waves, you can produce power, and this can be a massive advantage to expand to more remote locations and conduct critical research to advance humanity. I hope in this video I was able to show you that renewables are about far more than just fixing a problem. Our future relies on our ability to produce energy renewably, not only because of global warming and we're physically going to run out of non-renewables, but also because in order to advance and raise living standards, we need unlimited power that can be provided anywhere, anytime, and that's exactly what renewables excel at. I hope you enjoyed today's video, and I'd love to hear what you believe is the biggest innovation of the 21st century. But for now, that's it for me, and I'll see you guys in the next video.